Welcome to another insightful session here, and where science meets innovation. And today we are honored to host Dr. Simpy Sanyal, an associate research scientist in South Korea, and she is she specialized in plasma-based thin film technology and advanced functional materials. So PhD in electrical engineering from South Korea. His research spans anti-corrosion coatings and including self-healing composites, something like that. So whether you are working in R&D, material science, or energy applications, this session is packed with insights into how smart services are shaping out next generation technologies, including the journey of Dr. Simpy Sanyal. So, Simpy, thank you very much. You have worked across a wide spectrum from solar cells to high voltage insulators and now plasma coatings in industrial settings. Could you walk us through your journey? What inspired you to pursue surface engineering and how do you see its future in energy and smart materials? And also to include your journey from transition from India to South Korea as well, please.
Sure, Dr. Habib. I will start. So, first, I will introduce myself. I am Dr. Simpy Sanyal. I am basically from India. I came to South Korea in 2018 for my PhD journey. So, I did my PhD from Sungkyunkwan University, South Korea, from the Department of Electronics and Electrical Engineering. But my work was basically focused on material science. So, as you know already, like thin films and surface engineering, so that is more focused on material science, so it is almost like some interdisciplinary work. Now coming to my India, like what I was doing in India and all, so I started first I did BTech from electrical and electronics engineering from a state government university in India, and after that I worked in a software company, like that is a multinational company, Converges, for 1 year almost. And after that I started masters. So masters was also from India, and in masters I did masters in power electronics, like that was electrical engineering department itself, but the specialization was power electronics. After that I was searching for PhD basically, so I was applying to some places. In that time, I have started work in one institute, which is funded by DST, like Department of Science and Technology. In that, the my professor was working in solar cell. But that time I was like just grasping the basic theories. I have not started like deep. I never went deep into research that time, and I was applying also to many places. So after that, from my Korean professor I got some invitation, like okay, you can come for the interview, and if it is okay, then we can proceed, like that. So that professor was working basically into solar cell itself, so my plan was uh, come to Korea and do my PhD in solar cell. That was my plan. So when I came here, and after that I joined the same lab. um, but after like 2 to 3 months, my professor main work was basically solar cell. Like he works basically in solar cell. But that time he got some project from KEPCO, like Korea Electric Power Corporation, that is like electrical and transmission company in Korea, national company. My professor got a project from there, and that project was like how to increase the reliability and lifetime efficiency of insulators or dielectrics, we can say. The other people, like my lab was also international, like there are many people from Pakistan, South Africa. I am also having many Pakistani friends in my lab actually. And like there were people from China and Vietnam, like that we were having, even Brazil also. So but my professor told me to join that project, like insulator project, because my background was from electrical and electronics engineering department. So my professor told me if I want I can join this one. So that time there were already many students who was working in solar cell and all, and it was basically not my decision to shift to that one, my professor's decision. That is my honest review. That was never my decision. So anyway, after that I started working to like dielectrics. So the work was like the project which we got, that one was how to enhance the lifetime of dielectrics or insulators. So the insulators I'm talking about, that is like the insulators which we are using in transmission lines. If you see any transmission lines, you will see some like porcelain insulators. Basically the work is to support the conductors and to provide isolation, because I have seen you also work in microgrids, right? So I don't have to explain much about insulators. So okay, so that insulator only. So insulators consist of ceramic and metal part, and ceramic, metal and cement part. So my work was to work to make some functional material which can enhance the lifetime of the insulator. Like that I started working for that. So I have used that time some polymer composites and some inorganic material, silicon seeds, and then cerium, yes, cerium related, and I did my work. So I completed my PhD almost like 2023. And after completing my PhD, like up to that time I have not received my degree, but I have started applying for jobs through Saramin. Like in Korea there is some website, Saramin, like LinkedIn, it is also some website. And if you want job or internship also, you can apply through that website. So I was continuously applying, and finally I got one offer. That time I have not received my degree, but they told me, okay, like everything is completed, so you can join. So that company was my recent company, like the company in which currently I'm working. That company name is J&L Tech. This company is having its global presence in Slovakia, in US, Ohio City, and Vietnam also it is there. Like it is having global presence, but it is not like Samsung also. It is like a mid-scale company in Korea. But the good thing about Korean companies are they are having their R&D sectors also. Like they really want to do research and enhance their product. For that, they are having their R&D. So in my company is basically work for like my company develop different kind of functional thin films. Any material like silicon, carbon, or any kind of metal composites also based on the customer requirement. And my company also manufacture the instruments required for deposition, like PVD, PCVD, ALD, and even the measuring instrument like SEM, even your scratch tester, which can basically the work of scratch tester is to check the adhesion. Like if we are making some kind of thin film, how much it is adhered to the surface, that one we need to check. Otherwise, it will not be reliable maybe. So those kind of instrument also my company makes. So after that I started working in this company almost from May 2023. I have started working. Initially I joined as a like research scientist, and after that I got promoted as a associate research scientist. So yeah, things are going on like that. Now you
Very
can
nice.
ask me. I think I have introduced so much things about me.
Very nice, very nice. That's good. So, and I think so. You already mentioned all the things almost. And what's your advice for students trying to decide between academia and industry? And one thing before that, the language barrier you are facing, not facing language barrier in South Korea during job.
Yes, that is there. But actually, I will tell you, when I came here in 2018, that time like most of the students or any like normal people also who are not like in any country there will be different people, right? Some will be very highly educated, some are like they are educated but not that much like that. Okay, so previously it was like the students also cannot speak English, even they cannot understand in 2018 when I came to Korea. But now the things are changing. I mean, in my company, when I talk with my in our department, research and development department, there is a manager is having almost like 15 to 20 years of experience. Even the director, they can speak English, they can speak English. And other people like other students also, mostly they are masters, so they can manage. It's not like they can speak very fluent English, or if I will speak very fluently, maybe some people will understand. But director and manager understand fluent English also. But other people, I have to speak little slow. And in Korea there is a English known as Konglish. So now I am very much into Konglish basically. So I know how to make them understand. Even the condition is like when we deal some international projects also, like we were working with Germany, some professors. So if they don't understand sometimes, European professors are having very different English dialect. So that time they will ask, like I will be there and I basically become the translator, like from European English to Korean English, like that. And now I can manage, like I am not very fluent in Korean, I cannot speak very fluently, but I can understand and I can manage, like that. I can manage.
Very
The
nice.
thing is like that. But
Yes.
yes, if some students wants to come to Korea, I will ask them, it will be very easier for them if they can learn the language and come. That will be more easier.
Okay, okay. And about the second part of the question, what's your advice for students who want to try to decide between academia and industry?
Okay, so I will tell about my experience. Okay, like when I was doing PhD and I was into academics, that time I do more research on for example, how to optimize the process, those kind of things, and after that to check the reliability and all. But my honest review is whatever PhD work we have done, I mean I have done, if you will ask me to upscale that, like commercialize and all, that will be very difficult, because during PhD we don't have that much time to think about the commercialization. Our basic target was to make the things properly, I mean to do the experiment, some results like we almost do 5 to 6 times to check. More than that we never do. And after that, paper publication, that was our basic target. So that time we were not having that aim to commercialize anything. But that was like PhD time. But now I know, if we really want to make our product working, then like any product, if we are doing, if we cannot commercialize it, then there is no meaning whatever we are working in. But if we cannot commercialize that one, that is having no meaning. So I feel like during whatever people are working, like you can see many papers, like many things people will do, but till you will not join industry, we don't understand that, like how to commercialize, like how to scale up the things, those kind of knowledge you will, I mean anybody will get after doing, like after joining industry. But some people obviously they can think that they are more into academics and they want to become professors and all. But I believe that if you are doing, like in academics when I was there, yeah, we are reading some papers and based on that we are doing some research and doing. But honestly, whatever written in paper, that one if you will try to do, that one will never come. Like I never got the same result. Okay, so I don't know how much time they have tried those things and did. But when we work in industry, we don't work for paper writing and all. Our client will tell us what kind of product they want, and based on that we do the research. So I think everybody, like if people are getting chance, at least for some years they can be in industry and understand. Like otherwise sometimes we will feel we are just working, saying many things, but everything is in paper. It is not product development. Till you are not doing product development, how will you understand whether it is useful for market or something you are doing in paper? So I feel like that. But maybe people are having different understanding or different perspective, so I don't want to be in some conspiracy or some kind of thing. I don't want to fall into that, but this is my perspective.
You are right, you are right. And also, I want to add something in that industry projects, for example.
Mm-hmm.
In addition to your comments, also there is some gap. For example, you can also suggest new novel idea of the project industry wants, and you are designing that project, and even you can include a novel idea for the publication as well. So I think so. When you are doing the industry projects, you can also be the part of your you can say PhD research or novel idea, something like that. Even the industry has no requirement for that, but this is the possibility. I observed this possibility. I think so. So it means industry in a short way, industrial projects can be both. Like you can blend PhD research, ongoing PhD research, post PhD research, and the industry progress both. But in PhD only, especially as you said, it's only these theoretical or publications and no practical impact you can see. So that's what I observed, and it's again the not the conspiracy and just the idea. So,
Yes, yes.
do you think what's the role the tools you are using, COMSOL or SEM, AFM, play in your
Hmm.
day-to-day work?
Okay, actually, I will add something more which you are telling. I agree totally, but I will add some of my points. Like my experiences when I was doing, like previously also, I have handled ALD, I have handled PCVD. Those are like deposition instrument. There are two kinds of, either we can use PCVD. PCVD means chemical vapor deposition, or we can use PVD, that is physical vapor deposition. So in sputter and all those kind of instrument falls into PVD, and there are like PCVDs. Basically, we use some precursor gas. That gas will convert to thin films. Like that, it works. Okay, so I will not go very deep into all those things. But what I'm telling is, previously also I have used those instruments, and my lab was solar cell lab. So all my friends were using those instruments. Like I know my friends who were using those instruments. So those instruments were not new to me. Though in my work, all the instruments were not required. But because my friends were using that one, and we used to stay in lab night time and all, like 12 o'clock, 1 o'clock, talking with each other and doing the work. So I know how to handle those instruments. So when I joined my company, that time also, I knew the basic function. But I will tell the difference. I just knew that time, like if any customer will tell me that you have to make some material, you have to make some coating or thin film over some sample. Maybe they have given us piston, for example, like in engines there will be some parts known as bearings, then pistons, then actuators, those kind of thing. If they will ask me, okay, you have to make it frictionless. Why frictionless? Because inside engine there will be very high heat. So some rotating parts. So if rotating part will rotate against some fixed part, so there will be very there will be heat generation, and it will be power dissipation also. So they want, maybe, like I'm just giving some example, they are asking me to make some coating which is like frictionless or something like that, or and that coating should have thermal uh, thermal barrier also, thermal barrier property. That is my core work during PhD. I can introduce any kind of functionality to material. Okay, functionality means like this only, like corrosion resistant, super hydrophobic, or if you want slippery, like that. So initially, like, so during PhD I already learned that how to make and design and how to optimize those things. So when I have started working here, based on the customer need. Now during PhD we know how to design, but we did not know that my instrument, I mean what are the things my instrument can do. I mean, I cannot open the PCVD and then I cannot change. Like if there is some kind of error in the instrument, for example, and seeing that the gas, like we use in PCVD, we are using some kind of gas, so that gas is varying, like the flow rate, CCM flow rate is varying continuously. So I did not know what is the problem. I will be like, the gas is varying, maybe the MFC problem and all. Then I will report to some people who will change the things, or if I will report to my senior, they will tell me maybe this problem, like that. Or sometime, inside chamber, if there is, especially in PCVD, if you are using pulsed, like there are two kind of sources. Sometimes we use RF and sometimes we use pulsed DC. So if you use pulsed DC source, in that case, if there is single dust particle also inside the chamber when you are doing the deposition, that time there will be arcing. Okay, but we did not know why this problem was happening, and we did not know how to solve it. But we can optimize the things and make the recipe, like that we do. But when we started working in company, whatever problem is there, because my company manufacture instrument also, we only have to open it. Everything we have to open, and we have to solve the problem. Why the problem is coming, we have to fix. So in these 2 years now, I can fully open the PCVD and I can again do it. But that kind of, and it is very much important. Like people during PhD we also used to think why we need to know how to maintain the instruments and all, but it is very much important, because if you don't know what your instrument can do, then you cannot, like, you don't know up to what extent you can work in that instrument. Like, maybe you want to change the source, maybe the whatever target the customer is saying, if that is not coming, maybe you need to change the source, but that kind of knowledge you will not have till you will not work in the industry. So that is my perspective. Like,
Yeah,
it's vast difference, like vast. During my PhD, whatever I learned, obviously I learned many things, but after that, when I have to do everything practically, that is like from many, like, it's vast, it's very different actually.
very nice. Very
So
nice. So, that's nice. And what were some challenges you faced as a woman, as a lady, as a in a highly technical field, and how did you overcome them?
see, challenges means in my industry, like in my place, the challenge which I mostly come is like, we have to use very heavy, the gas chambers, like when we use we use different gas precursors like C2 acetylene, methane, sometimes silane. That gas chambers, like, we called it gas cylinders. Yeah, the gas cylinders will be like 47 liter and also it will be very heavy, right? But from South Asia, how the perspective is, South Asian people, girls cannot handle like that. Okay, so I was also having the same perspective, right? But after coming to Korea and working in industry, my perspective totally changed. So yeah, there is, like, if we handle it properly, we can roll it and connect the things, those kind of things. That is one challenge. Another thing is like, some chambers will be very heavy, so basically it's like physically challenging to handle it. So you need some male, like some help from people, and you have to ask them then only. Those kind of things are there. And sometimes it's like, if you are working to, like, if you are talking with like workers and also, sometimes maybe they believe that if a girl is saying so, maybe what they know, or like that something, it's like, there's every time don't follow. Like, if you are saying please do it, I think this is the problem, so every time they don't follow. So like that, those things are there. But I think everybody should experience one. I mean, it's totally transforming experience. I feel like that.
Very nice. That's very nice. And for example, what skills, technical as well as soft skills, do you believe students should focus on during their studies?
Technical skills, like I'm telling, when we do our PhD, like I did, like whatever, like thin film and surface engineering related, my PhD was. That time we are only focused on our PhD work, but that sometimes does not work. Like, um, if your work is totally theoretical, after that you can get only postdoc or academic positions only. So if you like, and like, if we can convert the postdoc to professorship, then it is different. But if we cannot convert into professorship, after that there is instability. Like, if we are getting new project, then okay, otherwise we have to depend fully on professors. Those kind of things are here also in Korea. So I think, with work, we should develop some soft skills also. Like, if we are working, like some people work are totally theoretical, okay, so in that case they can basically search, like, their seniors, what kind of places they are working, and if they are, like, what kind of skills are required to get that. So those kind of things also they should practice, because I know many people who are very talented, having very good papers and all, but because they were having very theoretical work, so it was difficult for them to get afterwards. Like, and right, like some, like in Korea there are mainly semiconductors work, but if you will go to some other places, maybe that country is having some different kind of work. Like that also there is so much problem. So I think, yes, it is very much important to gather some soft skills. And managerial skills also are very much required. Like, if you will see nowadays the positions, they will ask that the person should know how to handle the projects and all from scratch. But during our academic CV, we never mention that. Even if we do it during PhD, we have to handle the project from scratch and write all the reports and all, but we never mention in our CV. But those things I think we should mention. That is also very important to
That's
write.
good to highlight. These points are very important, yes. And how important are internships, networking, and industry exposure during graduate school?
Graduate, actually, see, if you will ask me about my network, I am having very less friends, like one, two maybe. So my networking is not good. But yes, I know many people who got many benefits due to networking, and they are doing very good. But in my case, I am not, I am little introvert, so I could not make much friends and into so much networking and all. That one I could not do. So I cannot comment much on that.
Okay, that's nice. And the final question, what's message would you give to young students from developing countries like India, Pakistan, or other Bangladesh, and aiming for global STEM careers?
I think it's good only, like I will speak about my country. Okay, like in India, whenever I see some Quora post and from LinkedIn, what basically people are facing, that they face money issues. Like for some time the fellowship will come, and sometimes like in 6 months and 1 year they are getting fellowships. But like when I started my PhD, I was not married, so I was not having family responsibilities and all. But people are having family responsibilities during PhD. Many people are having, so they suffer due to money issues. And if you are not able to support family, it will be much emotional issues, and after that the work will not be done properly. But yes, when people come, like in my lab at least, there was no money issue. Whatever fellowship professor told he will give, that one, like totally consistent. Like what my friends have suffered in India, those things I have not suffered in Korea. But we are having also our challenges, like we don't have family here, so if we are falling ill or some problem, we cannot go to our country during festivals. Like one of my Pakistani friend, after he completed his PhD also, professor is not leaving him to go to his country. So we were just discussing, your family will 100% forget your face also, that kind of condition. He also came with me in 2018. He completed 2024. One time only he went to Pakistan. After that, he could not go yet. So there are challenges, right? In
Yes.
our case, also there are challenges. But I think, yes, it's not very easy to get. Like even if I will now try to get into other country, it's not like because I am working in industry or I am having industrial experience, it will be very easier for me. No, but we have to be consistent and continuously, if we will try, and then we can get like that only.
Very
But
nice.
it depends on luck sometimes. And yeah, obviously cover letter, SOP, and those things are also important. CV, because I know some people will send CV, like they will write that badminton is their hobby, and all those things does not matter, right? So those are also there, but luck is also there. Like if you are getting like that.
Very nice, very nice. Thank you, Simpy, and especially for your honest reviews as well, and for this enriching conversation. And your work truly shows how deep science and practical industry can intersect to create smarter, more resilient materials for tomorrow. So, for our audience, if you found today's discussion insightful, don't forget to share it with your beloved ones. Explore more about plasma coating, nano-composites, and thin film applications in real-world settings. And also, up till next time, keep innovating on the surface and always look deeper into the materials that power our world. Thank you very much and
Sure,
have a
thank
nice
you.
time. Thank you.
Have a nice day.